My name is Deborah Breitfeld. I'm the Executive Director and CEO of the New Mexico Tech Council. And Emily Bennett is on with us, and she is our Marketing and Events Manager. Thank you so much, Emily, for coordinating this for us today. So the New Mexico Technology Council is a member-led organization committed to supporting the state's tech ecosystem through networking, valuable programming and professional development, public policy advocacy, workforce development, and targeted promotion of our members. Our programs include, to support our members, monthly peer groups, such as this, our big data and AI and cybersecurity, women in technology, and 3D printing. So we typically have those meetings once a month or every other month. We have 2 annual signature events, our Women in Technology Awards, and which we're having again June 10th. You'll see a little bit more about that, and our Experience IT conference we have every fall. So Dr. Zeng, we might be reaching out to you as well to come back and join us for that, and or connect us with some of your peers. During the legislative session, we work on issues that are important to the technology community as well as economic development. The big one this last year was broadband throughout New Mexico. Since we are such a large geographic state, the pandemic gave lots of people all sorts of challenges related to internet access for schooling and business. Then we also work to promote our members and provide features about their activities. We're very fortunate to have a great support system of sponsors. These are our community partners. As we talked about, Marcia L is on. The city of Albuquerque is a great supporter. Fat Pipe is a shared working space here in Albuquerque, as well as all of the others that you can see. We're very appreciative to our community partners. So we have a number of events that are coming up in the next couple of weeks, and just wanted to share those with you. Women in 3D Printing is tomorrow evening, which is a great group of people talking about the latest and greatest in 3D printing. Eagle Point Funding is giving us a presentation on Tuesday, May 25th. Our Women in Technology Happy Hour is going to be a great event, battling bots at the Electric Playhouse on Thursday, the 27th. And then, of course, our June 15th follow-up peer group event with Trilce Estrada from the University of New Mexico. So you can go to our website to register for any of these events. As I mentioned, we have our 13th annual Women in Technology Awards. That's Thursday, June 10th. This is an event where we recognize this year will be 7 outstanding leaders in technology, women throughout New Mexico, from Socorro to Santa Fe. We've got private sector, we've got educators, and we're really excited. We have a fabulous keynote speaker, JJ DiGeronimo. And so she has dedicated her life and her career to empowering and working and supporting women, particularly in the STEM arena. And these are our sponsors that we have for our experience, or for our Women in Technology Conference, which again, we're very grateful to them to support our organization and this program. And hopefully next year we'll be able to have it in person. Last year, the pandemic struck just about a week before our event. And this year, everything decided to open up just about 2 weeks before our event. So just the timing sometimes. But this will be a virtual event. So please go to our website and register. Andrew, I was going to turn it over to you now to talk about the peer group, and or Michael, if you'd like to.
Sure.
Yes.
Michael,
hello, everyone. I'm Michael Maestas from Sage Core Technologies, and we'd like to thank you all for coming here today. Thank our wonderful speaker. And we have a phenomenal group here that's worked really hard to put all this together. And I'd like to give them some credit. Andrew, Tony, Marcia L, Brooke, Eric, and of course, Deborah. You've been instrumental in this as well too. And I'd like to thank you all. Andrew, would you like to say a few words, and we'll just kind of go down the line and introduce our group and just say a couple words so everybody gets to know us.
Yeah, actually, I'd probably move on to the bio, if you don't mind, Marcia.
Oh yeah, no problem.
Yeah. So first, before I introduce our distinguished speaker, I'd like to say that I'm personally very excited about this particular talk. Of all the areas in data management, metadata and open data are one of my personal favorites, and I really believe that the development of that is going to be the key for data management for years to come. And we're going to see a lot of changes here. And given the audience that's here, I know that many of them agree, and we're in for a real treat. So with that, I'd like to introduce Dr. Marcia Zeng. Marcia Zeng is a professor of information science at Kent State University. She holds a PhD from the School of Computing and Information at the University of Pittsburgh. Her research interests include knowledge organization systems, which are taxonomies, thesauri, ontologies, including linked data, metadata, smart data, big data, database quality control, semantic technologies, and digital humanities. Dr. Zeng has authored over 100 research papers, as well as 5 books. Her research projects have received funding from the NSF, IMLS, the OCLC, Fulbright, and other organizations. She has chaired and served on communities, working groups, and executive boards for IFLA, SLA, ASIS&T, NISO, ISO, DCMI, ISKO, and W3C. And as someone who formerly employed by IBM, that's a lot of acronyms, even for me. Currently, she is serving as the chair of the Digital Humanities Curriculum Committee of the Global iSchool organization, and as an executive board member of the International Society for Knowledge Organization, otherwise known as ISKO. So without further ado, please allow me to introduce our guest, Dr. Marcia. Marcia.
Okay. Thank you so much for coming to today's. I would focus on something that everyone probably already expert and already know. So I hope this will become a chance for us to discuss and work together. What I was going to share is the pilot study and the experience, as well as some trends that we can identify. And so I'm going to, should I start to use my PowerPoint?
Oh, I left you a message. Okay, well, there's a couple
Yes, and Emily's gonna, if everyone could please mute themselves.
Anyway, it's about big data and open data.
Actually,
She's
the
excited.
presenter should have the ability to mute everybody. That's what I understand.
I closed the thing. Well, I closed the thing, but the issue is one thing, you know, the
Dr. Zeng,
on the back cover.
you might need to go up to the right-hand corner.
The link that says sandia.gov/.
Ellen Klein, mute yourself.
Oh shoot, I'm supposed to be introducing myself. Oh my God, well, I guess I can't.
Mute yourself.
Oh.
Thank
Ellen
you,
Klein,
Stacy.
mute yourself.
Okay, Dr. Zeng, take it away, please.
All right, I will start share my screen. You can chat and put question on the chat room, or I can try to answer later. Okay.
Hey, Nami.
This session will share the research findings and the pilot study on ensuring the fairness of metadata. Here, FAIR is F-A-I-R. The open data and open science environment requires the published digital resources are findable, accessible, interoperable, and reusable, fair. The principles refer to 3 types of entities, including data or any digital object, metadata, that information about that digital object, and infrastructure, 3 types of entities. In this session, the focus will be on metadata. After an introduction of the FAIR principles, the presentation will report the new efforts of the Aggress, which is a global public service provided by the FAO of the UN. We will first have some background about open science. Open science is the movement to make scientific research and its dissemination accessible to anyone at any level. So this scientific research include publications, data, physical samples, and software. Usually, open science is transparent and accessible knowledge that is shared and developed through collaborative networks. Plan S is the one that addresses the open access part. This is an initiative for open access publishing that was launched in September 2018. The plan is supported by a lot of international consortia and research funders, which requires that with effect from 2021, all scholarly publications on the results from research funded by public or private grants provided by national, regional, and international research councils and funding bodies must be published in open access journals on open access platforms or made immediately available through open access repositories. So we can see that kind of requirement is now coming. The United States Federal Data Strategy has released for a while, and we will later check the USA's Datagov website, which provides thousands data sets. And a new resources, it's a resources.data.gov was also launched in 2019. That is an online repository of policies, tools, case studies, and other resources to support data government, management, exchange, and the use through the federal government. So in the open science and the open data movement, how can we make sure that we all meet certain principles? So these FAIR principles are very important and widely used. The first step in using and reusing data is to find them. And you can see the principles refer to 3 types of entities: data or any digital object. And then second one, metadata, which is information about that digital object. And third, infrastructure. Sometimes you can see the word spelled out with metadata in parentheses,
which means for both data and metadata. Metadata and data should be easy to find for both humans and the computers. Machine-readable metadata are essential for automatic discovery of data sets and services. So this is an essential component of the whole process. Once the user finds the required data, then the user needs to know how this can be accessed. So the accessible requires data and metadata are retrievable by their identifier using a standardized communications protocol. Then metadata are accessible even when the data are no longer available. This is very, very important. The data usually need to be integrated with other data. In addition, the data need to interoperate with applications or workflows in the analysis, in the storage, and in processing. Therefore, data and metadata must be interoperable. Those details give us the guidelines of how to reach the interoperable data and metadata. Reusable. The ultimate goal of FAIR is to optimize the reuse of data. You don't want just create data silos, right? To achieve this, metadata and data should be well described so that they can be replicated and or combined in different settings. This R1 is directly referred from the first findable principle. As you can see, the findable F2 defined by the R1 below. So the reusable directly connected with that. This is summary of the FAIR principles. We will take some examples to show the new opportunities at the open science movement. You can see the FAIR principles and the importance of metadata enabled. We see all of this and take the new opportunities. First, we can see a few examples of the tools developed. The Dataverse project is an open source web application to share, preserve, cite, explore, and analyze research data. It has been implemented by a lot of different institutions all over the world. Each Dataverse collection contains data sets. And then each data set contains descriptive metadata and data files. So if it's a organizing way, that Dataverse collections may also contain other Dataverse collections. DCAN is a community-driven, free and open source, open data platform that gives organizations and individuals ultimate freedom to publish and consume structured information. Pay attention to the term structured information, mainly the metadata. And this is very popular and has been used by Datagov and many US government agencies. open data provided by agencies are usually research-based with high quality and very well documented with rich metadata, as we will check later from some examples. And they usually provide the available data sets through dedicated web services. They have their own web services. We mentioned that the tool DCAN, this US Department of Agriculture, used the DCAN to provide its services, dedicated services. I have some numbers to show you how quickly it was growing. The previous example was agent provided. Now we're talking about putting all this agent inventory together on centralized. The example here is Datagov, the USA's central clearinghouse to research and discovery. Datagov was launched by the US General Services Administration, GSA, in about May 29. At that time, there were 47 data sets. And very quickly, it has grown to over 200,000 data sets. You can see the organization types, where the data come from. They could from federal agencies, could from states, counties, and cities. I also would like you to check the format. A long list is much, much more complicated. Think about how to handle and provide access to this huge and complicated data sets resource. When you go inside, for example, check the Department of Agriculture, how many data sets provided. Yeah, 1.8K. But it's from where? Again, there are categorizations you can check by the sources, as well as the dataset type and the resource type. Similar to the Datagov that we just talked about in the USA, there is a similar one in UK. The portal is Find Open Data. It has different categories. For example, I chose environment, which tells you what are the coverage. And then by just recently, there are over 7,000 available. The EU Open Data Portal grows very fast. As you can see, only 5 months, how many more data sets are there? The search data sets give different categories as visualized on the top. I chose the one related to the agriculture. Then I got over 20,000 data sets. Each of them, you can find different downloadable formats, as well as on the top, I've highlighted that look by categories, look by similar data sets, and also the quality. So what the quality means? This portal allows us to filter by metadata quality. What are the dimensions? As you can tell from this page, the FAIR principles have been used, plus the contextual information. Each dataset will be measured according to those dimensions. For example, I choose this top 12 catalogs and wonder why those are ranked in the top 12. It's because the findability or any other features on the very right side, it's weight. That has the ranking according to the measurement and give you, say, this is sufficient or good or bad or excellent. Very interesting. You can find more information about this metadata quality assessment tool with the detailed explanations of the criteria. OpenAIR is also a huge repository. It's a European project supporting open science. It provides a technical infrastructure harvesting research output from connected data providers. Seeing the new opportunities in the open science movement. What will you do? The next, we will focus on the Aggress efforts of integrating research data sets metadata. Aggress is the International System for Agricultural Science and Technology, a global public service provided by the Food and Agriculture Organization, FAO, of the United Nations. Aggress can be seen from 3 points of view: the network, the database, and the web portal. As a network, it has over 450 institutions and 150 countries contribute to this. The providers could be a variety of types of providers. As a database, this is our most interesting part. It has millions of structured bibliographical records since 1974. And it's multilingual. It has users from all over the world, especially the third world countries. The openness and the flexibility of the web have created both new opportunities and new challenges for data publishers and data consumers. Where are we? Are we data publishers? Are we data consumers? So how to represent, describe, and make data available by publishers in a way that it will be easily found, understood, used, and reused by consumers. The next step to include research data sets services, maybe one of the ways to provide links for accessing the datasets, portals, and services for all the food and agriculture and other themes from all over the world. That means you, on the web page, provide links to data.gov, provide links to data.gov.uk, etc. Another option It's like those open data provided by centralized way, starting a big service like Datagov for food and agriculture. That means you harvest all the metadata from the world and become an independent service parallel to the existing bibliographical Aggress. Would that be workable? Another option is to extend the existing Aggress, integrating the research data sets metadata. You can see the current one, when you check content type, it has bibliography, book, conference, journal article, thesis, and other. Can we extend this and integrate research data sets here? This option led to a new effort with a pilot project. It was aimed to extend the existing Aggress to integrate research data set metadata. So you're not only searching by publications, you can also search by data sets. And the metadata considerations will be needed. I will talk about this next. In this pilot project, it started with the USDA, the United States Department of Agriculture, from the National Agriculture Library. Through their open research data services, there are several steps. First, we have to find out what's there. So analyze datasets metadata by going there and check what are available and what are provided. This was done in the 2019. There are two sections when you search and find any metadata. First is the basic metadata. So we got all the ideas of what is data, what's the spatial geographical coverage, what are the owners and the participators, and where you can get the full data. This is basic metadata. There's also extended metadata, which gives you a lot more details. All of the metadata records are also stored as JSON files. When we analyze metadata, we first check what elements are used in describing and documenting the data sets. On the left side, they are presented in the main part. Then I can also see the details, open each of the parts that can be contained the sub-parts. You see that corresponding element? Then we will take a look at the structure, not just the element name. Why? Because each element on top level can be open with subset, but there could be the same element name. For example, I check this one called Food and Nutrition Assistant Research Database. When you look at the distribution, this database can be distributed, downloaded from different URLs, maybe have different names, but they all have the element called title. And when you search title, what do we mean? We need to understand the structure. The analysis then goes on to the data values. For example, in the keywords section, it contains very rich schemes and taxonomy data values. The sources could be different thesaurus, could be a ISO standard, could be a taxonomy. If I go on, you see how complicated in the JSON file. The USDA has done an excellent job. You see, for example, when we continue to look at the data values, you can see that full taxonomy has been applied at all levels, from kingdom to species, in the original metadata records. Wow, so impressive. The spatial element can contain simple, like this one, or very comprehensive geodata values. You see the spatial column on the bottom one and the right one. Wow, very impressive again. The next analysis is the metadata schemes used. The USDA JSON scheme is based on what we call Project Open Data Metadata Scheme version 1.1, which is based on DCAT. So you can see the relationship, Dublin Core, DC there, and then DCAT is the data catalog vocabulary of the W3C. Itself is the application profile of Dublin Core. Then the Project Open Data Metadata Scheme, ODMS, is based on the DCAT 2014 version, and it's used by the USDA. After all of this analysis, it led to the step B, mapping based on metadata schemes. The involving schemes we mentioned about that are what Aggress used, which is the application profile of Dublin Core. And then the USDA JSON files use. They used the one based on the Project Open Data Metadata Scheme, which itself is the DCAT application profile. And DCAT was built also based on Dublin Core and extended to cover research data. Well, I won't go into the detail, just want to show you on the left side is Aggress own application profile, Dublin Core based, the lots of elements. And DCAT led to the Project Open Data Metadata Scheme that used by the USA government and by this. We can see that come from DCAT, and DCAT came from Dublin Core. Yeah, on the left side is the DCAT 2014 edition. You see a lot of starting with DCT. That is from Dublin Core. Okay. So can we map? Yes, because they all have the basic root together. So we try to focus on achieving interoperability at the level of schema, at the level of records and the repository, and think about possibilities and how you can accurately do this and whether you really need to crosswalking and mapping everything. You have to be realistic. The lower part was the spreadsheet you created to compare and crosswalk the different schemes that used. This is just informational slides. I compiled this marked what the new DCAT 2020 version mainly created. You probably have seen the ACES webinar on the DCAT ontology. This was still fully compatible with the DCAT version 1 that we talked about in the previous slide. This M2B also now need to modify the consideration and to include the both bibliographic and the research data. This will be ensuring its interoperability to support the management and access of bibliographical plus research data. You have to go to your original structure and modify the application profile and then implement into the database and the harvesting use. The fourth step is metadata integration. So the data now validated and mapped and cleaned up and converted to the Aggress application profile. And then enriched with the element and values that are used by the Aggress, then convert into Aggress RDF data. This is the final effort. After the pilot study, converting, crosswalking, and started to harvesting, what are the outcomes? In the May of 2019, after the pilot study, the new effort has resulted in a new function which enables users to search for over 1,500 open data sets through Aggress. Now, when you go to search the Aggress, you can see the filter, not only publications, but also data sets. When you search that, for example, when I search the food, I can decide whether you want to data set or want publication or both. And this led to all the downloadable data sets where Aggress provide is access to the data sets. So the metadata from the USDA was integrated here, and then the access through the USDA metadata to reach out. What about if I want to get the metadata? You access there, the source brought you to the USDA, to the particular provider, and where you can find the information and download use from there. Okay, understand that? Left side is Aggress, give the access to the USDA data. Okay, let's wrap up and check what are the major takeaways from this pilot study in this open science movement. The major takeaways from this pilot study at the Aggress is that it's time to provide metadata for open data through existing services, existing bibliographical portals, services like Aggress. Here, interoperability is the key to all these possibilities. For a metadata framework, ensuring interoperability is fundamental. Apply the appropriate crosswalking models and method will ensure the reusability of data, including metadata, and also reusable metadata and data enable extended findability of open data. So though FAIR. Thank you so much for coming to listen to this long session with a lot of details. You can follow the references and suggested tools, websites, services, and cases to explore and try to implement the FAIR principles in your future research and development. Here are some of the references. You pay attention to the new LoadBD 3rd edition that we just released at the December 2020, which included the implementation of a DCAT for research data, as well as the crosswalk with the schema.org. There are more references here. Thank you again.
Thank you so much. So now let's discuss. I already see some questions in the chat room. Anyone?
Well, thank you for that wonderful presentation. That was fantastic. I do have a question to kind of kick it off, and we can go down the list here of what's in the chat and if anyone else has any other questions. But in interest to kind of kicking off and get started. One of the challenges with data are the assumptions and how the data was collected that gives you that information. And so, you know, obviously those assumptions sometimes and sometimes not are part of the data set. But how is that handled in the framework of this type of environment?
You mean in this particular pilot study, right?
Yeah, for the FAIR framework. I mean, obviously a lot of data, you know, there's certain assumptions under, you know, because there's always assumptions when you're collecting data. You always have assumptions about, how the data was collected, under what conditions, sometimes certain, assumptions were made in processing or getting the data that's there. It may be sampling, it may be, inconsistent, it may be, there's always assumptions in various types of data, and those assumptions obviously vary. In the FAIR framework, do you get, or do you provide the background on how that information was acquired? Is that part of that structure and the assumptions?
That's a very good question, because the FAIR principle seems like not including the how you judge and how you evaluate the resources. I think it's a new challenge, and people are trying to find all the things from the existing available open data. But there are lots of questions and challenges. For example, in the academic world, there are problems of people claim, co-author claim things actually fake.
Mm-hmm.
Yeah, there was huge research proof that they try to put a famous person's name there or claim something. There were research data like, but FAIR principle did not go into that part. Yeah, how to evaluate. So more people trying to use AI to test, to validate. I would consider those as a new trend and a new area that some kind of work will be available in the future. Yeah.
Well, and you hit the nail on the head, because AI, by its very nature, has to assume assumptions. And so, it's not just the data; it's also the assumptions about the data that you make. And no, thank you very much.
Yes, if you see that the EU, this is not really just for the government, but there are others. So they have their methodology. I would highly recommend that take a look at the methodology. For example, they think about what they have, and
that's exactly what I was talking about.
Yeah, so the process, the assumption, and the tool itself, it's usable. Of course, we can probably not too difficult find the findability to measure and the accessibility. But interoperability is a big problem that you have to evaluate everyone and then measure that. This is more longer and complicated, and they require to check with the DCAP application profile. The reusability is also important. Some data, I think more European governments started to have new policies regarding the open data, the reuse of the data, the license and the access. So this will be a challenge. Interesting thing is that they also added a contextualized parts. Like you mentioned, some of the, whether it's modified or it's has the rise. In this, the real case, it's very interesting about the rating as well.
Yeah.
So this is probably the first one that really applied FAIR to measuring metadata. Yeah.
Yeah. So we have a question here from Steve Case. It says, all the examples are government, scientific, and academic. What examples of industry are driving towards fair standards? So I guess he's referring to private industry. Agriculture, I know, is one of the ones that you mentioned there as well.
Right. The Aggress data has been contributed from all over the world. They have the agreement. So I think another interesting thing is not in the science tech area, it's in the museums, because if you release everything from your museum, that means everyone can take the high quality TIFF image to create their t-shirt or create their ad, right? So how will you consider open or not open? Previously, when you request, you have to request a high resolution image in order to reuse that. And now there's several pilots from the Metropolitan Museum of Art started, and the Chicago Art Institute, and Cleveland Art Museum also started to open the ones that you don't have the copyright issues, the ones that are, and their open is CC0, so anyone can use that for anything. And this has been a similar challenge that you mentioned in terms of industry. I'm thinking about 6 years ago when the Netherlands opened up the museum and let them available, and others were just so scared, say how we can do that. We have to handle all the rights, even it is ancient, if it is from the war. There were interesting issue, for example, in Germany, when they opened digital images, the people came to claim that was their own, claim the ownership. So the museum actually lost this thing. So there's a whole museum field has several years trying and then doing things, but Metropolitan Museum of Art trace back after half year, after 1 year, after 4 years, what happening and what are the benefit that brought. And their data was very encouraging. They share in the thing, and had encouraged more museums to open their high resolution metadata images together. So I was think about this similar situation, complicated. Will also happen to any business in the different industries. Yeah.
So,
yeah.
and Ashley, and forgive me if I mispronounce the name, Faith had a question here. It says, it is usually still a closed system, but many manufacturing chains use FAIR-like standards so that they can ship, manufacture effectively. And IoT has a ton of examples of this. Although they don't necessarily call it FAIR, they use those standards. And so it looks like they're, and I've seen this too, like especially in the chains, like manufacturing, like Walmart has been using their new distribution chain. They actually use blockchain on that. But a lot of those types of industries, because obviously manufacturing and distribution, especially when you're talking global from suppliers, has become somewhat standardized with these types of practices. And do you know, it seems to be more kind of their own, but they're similar to FAIR, but they seem to kind of be their own industry specific kinds of things. And do you see that happening more and more often?
I don't have a real experience on this, so maybe someone could share more here. Yeah.
It's okay. I'm just reading the question that's there, and if you don't have the information offhand, that's okay.
Yeah, and then Ashley actually then had a follow-up statement might want to read.
Yeah, it says research has shown if you're mapping or crosswalking more than 3 data sets or schema, graph or hub models are better from an ROI perspective. 12 crosswalk mappings versus 8 hub models. Wouldn't you agree?
Yes, I think that's a reality. You don't want to silo crosswalking. Sometimes a better hub or hub structure could be better than I'm trying to find out some right, so
Michael, I think you could go to Sandra's question.
Yeah, I was going to go to Sandra's question here. So Sandra Nunn had a question. I am from healthcare. It seems the FAIR principles would be valuable to coordinate public and private research to speed things for things like the COVID-19 virus. And I will add to that for my own stuff that I know one of the challenges there is the protection of private data, but I assume Sandra's referring to more the informational whitewash data. Do you see healthcare really stepping into the FAIR realm at all?
yes. I think the questions could also be case by case and complicated, and how much you invest your time and effort to do this. In the health related area, the UMLS Metathesaurus is the best place to harvest everything together through one big hub. But there are, of course, the problems, even just for disease, for human bodies, there could be different codes, different way to talk about this. So those maybe go beyond the FAIR principles, maybe go to some best practices examples. Yeah. In terms of the COVID-19 related issue also brought us the problems that there was one big article with Oxford lab. So they collected a lot of sample data about the genes, about the changes of the thing. But because the metadata is not clear enough, you don't know what exactly that data set say, what the code mean, and whether you are there to reuse that to prove your case. For example, for any vaccine testing, right? So they published a big article in the scientific data article that is Science, from Science, talking about the no standards, not just standard way to describe the gene research data sets, but also how to apply, how to describe. That's no standard for the best practice. So those are reality, not just terminology or not just the results. People don't understand when you provide a data set. So
yeah. Well, thank you. There's one more question here from Timothy Cummins. There are great open data efforts in North America and Europe. Have you seen much movement in Asia, South America, Australia, or Africa? Do you know if there are plans and or push for open data in these regions?
That's I probably only can limit my understanding in Australia, New Zealand. They started to push this very well. Also in mainland China, that the government-funded data started to require. So Europe probably that have more countries now joined this. The policy surveys showed newer requirements and newer things from Europe, different countries. On the other hand, they also found, so when you see the situation like the COVID-19 pandemic and the trustness of data and misinformation, they started to think about the other way, how to fairly use and reuse the data and the restrictions, some kind of more restrictions coming now. So we will see the fix problems, I think. Yeah, that's just my
Thank you.
observation.
Marcia L posted here, and this is the last one that I've got here. I have found that metadata is great for providing information about the data set itself, but does not go into detail about the data found in the data set. We have added definitions about the fields to our metadata at the city, and she's referring to the city of Albuquerque. And so do you see that as an issue, these definitions about the data and the addressing of that?
Yeah, that's similar to what the Oxford lab released. Yeah, you inside of your data, inside your database and the sheet, how will you be able to define them and what kind of contextual information is there? And you just remind me the year before in this ontology summit, that's the USA, but extend to other place, has a whole year discussion, several months about contextualization. So anything you use, you have to have contextual information. Yeah. So description metadata is one thing. The usage metadata is another thing, right? And then there are other ways. So how will we be able to see it? So I would suggest also check the ontology summit. And this year is about ontology. Last year, all about knowledge graphs. What are the fundamentals? What are the components? What do you separate the infrastructure with the way you carry the knowledge graph and the show? So the ontology summit has several months, every Wednesday noon for the more a shared experience presentation and then discussion. And then at the end of the summit, we come up with a white paper, summarize, define, and make suggestions. So last year was about knowledge graph, and the year before it's about contextualization. Yeah, I would think this is probably no answer to this, but best practices can be found. Right.
Well, thank you for that. And on behalf of the New Mexico Technology Council and everyone here, we'd like to thank you for your wonderful presentation. Deborah, if you'd like any closing words, or Andrew, we'll go ahead and provide any closing remarks, and we'll, in respect of everyone's time, wrap it up here.
No, I just like to say thanks much, Dr. Zeng, for sharing your knowledge and experience, and to anybody in the community who's interested in the high level concerns of metadata or the details, reach out to us at NMTC data, nmtechcouncil.org, and perhaps we can continue this thread as we move forward.
That's terrific. That's terrific. Yes, thank you, Dr. Zeng, so much for joining us today. And Michael and Andrew and the committee, thank you for putting it all together. And Sandra, thank you so much for the introduction.
Yes.
So we'll look forward to hopefully seeing you again soon and staying in touch.
Yes, let's work together and try. It's not easy.
Definitely.
Terrific. Well, thanks so much, everybody. Have a terrific day.
Thank
Thank you. Thank you. Okay, Sandra, congratulations for your graduation.